Hello everyone, my name is Siamak Musabi. Today I'm going to make another program on Eco Structure Control Expert, which is the software for the Schneider processor. Uh, Today what I'm going to do, I'm going to make a debouncing program, and I'm going to use my DFB, which is derived function block. So without further ado, let's jump into it. So I'm going to start from the beginning. I'm going to go to new. So I'm going to use my processor. I'm going to use that processor BMX P34 2020, which is Modbus and Ethernet. I'm gonna hit OK, and then here we go. So we have all that component which is available on the left pan. I can see my processor. I don't want to put any IO card on it. I just work one small program. So, and we're gonna test it together. So let's try to open this one. So I need to use DFB type. So our project name is debouncing. So what the debouncing is, sometimes you have the switch and or push button, whatever, and you you press that push button, and because of the mechanical component that push button has, it might bouncing a little bit, and you have to make a timer to debounce that bouncing and get the right signal to the right output. So I'm gonna use debouncing. Name is debouncing. So it gives me some components, some input, output, input, out, public, private, and sections. So the only input I need switch. That's my input, and my output is gonna be a relay, just a name. So it can be anything output. So probably that's all I need. I need two timer as well. I'm gonna make that timer on the logic when I'm making it. So let's minimize that guy. So what I have to do, I have to make new section, and I'm gonna call it test debouncing, and I'm gonna use that as a structured text language. I can do anything. I can do ladder logic. I can do that function block. So I'll do that structured text. When I'm gonna call that function block, I use it on the another language like function block. So let's let's minimize that. Let's open new sections. I call it test. I say yes and okay. Yes, I have that test over here. So let's make some command here. I will say this is a control logic for the bouncing program. Okay, so I'm gonna call those two timer first. So what I need to do, I need to call uh, time delay, on time delay and off time delay. So I need two timers. So I need bouncing when we get that switch off, we need to debounce, and when we get that switch on, we need to debouncing as well. So let's call that timer. So I'm gonna get this timer, TON timer, or time on delay timer. So let's go to the library. I need that timer over. Okay. Time on delay timer. And let's call it T1 TON. So we know that T1 is TON timer. And I get the other timer. So and this one is gonna be TOF, or time on off delay timer. Time off delay. So time off delay timer. I'm gonna call it T2 TOF. So that's two timer which we are going to use on the program. So what we're gonna do, we're gonna say that input which is going to trigger that timer is OR switch. And the time we're gonna be just debouncing that switch is, I would say, maybe 2 seconds. Okay. And I don't need this two guy right now. Maybe I'm gonna use this like timer Q or timer down bit is on the program. So I'm gonna use this parentheses, and voila, that's okay for that timer tier on. And I'm gonna do the same thing on timer off delay. I'm gonna use the same switch. I'm gonna say switch. It's gonna trigger that timer as well. And for off delay, we can put T hashtag 3 seconds. Okay. And I have to close that parenthesis and semicolon. We should be, yeah, that timer is set up. Wait more time, there is no error, no warning. So what I'm going to do, I'm going to start programming. This is so simple program. So I'm gonna say if switch, that means if switch is through, and T1 TON, which is time on delay timer, dot Q, and or not switch. That means when switch is not active or in false state switch and T2 underline TOF dot Q, and this is the holding contact, and which is the relay. Then we can do relay. We want to be relay true or 1, else you want to be relay off. And now I would end that program with and if. Okay, so okay, semicolon equal. Okay, and I'm gonna analyze it. That's well, we don't have any issue. I'm gonna rebuild the project. So everything looks good on here. So we already made our function block. So this is reusable function block. So you can reuse this function block anywhere you want to implement that debouncing program. So I'm gonna go ahead. I'm gonna go to the main program. I'm gonna call my function block in main program. I have to make new. This time I'm gonna just call my program with the function block. So this is going to be debouncing that's a name. You can name it whatever you like. So that's okay. We create that section. So I'm gonna open that section. I'm gonna call my function block on this section, and I'm gonna call my function block. So it was, yeah. So we already have our function block. I'll make it like a bit visible. So that's a function block we made on that DFB. So I can make a variable for that switch. So I will say input, or I can say start. Yeah, make it bold, and I would say output, make it bold for this. That's all. Our function block is already made, so I'm gonna test that function block. So I'm gonna just analyze it one more time. Everything is okay here. I'm gonna go connect to my PLC. So I'm gonna transfer our project to the PLC and let the PLC run after transformation. Yes, build project and transfer. Confirm. Hopefully it's gonna work. So yes, okay. So we are online with that PLC. I'm gonna force that a start. So after 2 seconds, we have to see the output is on. I'm gonna save set value to 1 2. Yeah, that's output is on, and when I turn it off, it has to stay, output has to stay on for 2 seconds and turn off. Yes, so that means our function block is working. That's a small program, but it's really useful. And so as I mentioned before, it's a reusable function block, so you can call it again and use it to another program. So let me call it, okay, let me call that function block again, debouncing function block, and this is gonna be function the bouncing function block 2. So I can do like start 1, boom, and these are separate programs, so you can do relay 2 or relay or output 2. Output, it's just a variable name, output 2, boom, and let's test that program again. Let's transfer it to the PLC. Yes, I need PLC run after transfer. Build it. Yes, we are online with the PLC. Just a second. Yes, we are online with both function block and PLC. I can test both of them. Let's try the one we recently made. So I'm gonna set it to 1. Takes 2 seconds. Output is on. I'm gonna take this one as well to 1. Test it. 2 seconds. Output is on, and I'm gonna turn start bottom off. Set to 0. 2 seconds. You get the output up, and for the second function block I can do that 0 start, and output is off after 2 seconds. So you can use this function block 100 times. If you have like the same program, you don't have to write the whole program, so you can use that function block. Thank you for watching. I appreciate your patience. So please testing.